class, and welcome to section 11.6, which is adding and subtracting of rational expressions. By the end of the lesson, you will be able to find a common denominator for the rational expressions in order to be able to add and subtract them. Key piece of information to note that in order to add or subtract, both polynomials need to have that, both fractions need to have that same polynomial in the denominator, aka a common denominator. So just like when we did regular fractions, you needed to have common denominators, the same goes for these algebraic fractions where we have variables involved. The exact same expression needs to be on the bottom in order to add. So, steps here, we're going to find the common denominator. Once we have that, then we add or subtract the numerators, depending on what the problem is asking. And then the last step is, if possible, we're going to simplify that down, seeing if they have any common factors that we can cancel out. So this first example, we've got 5n over n plus 3 plus 15 over n plus 3. Notice, we already have that common denominator piece, so there's no work to be done with that. So then we simply move to adding the numerators. So I have 5n plus 15. We can't actually combine those because 5n has a variable and 15 does not. So we're at 5n plus 15 over n plus 3. Now we're going to double check and see if there's anything to simplify. Up top, I can factor out a 5 from both pieces. So 5 and then in parentheses n plus 3 over your denominator of n plus 3. Then since those factors match, we're going to go ahead and cancel them out. And our answer to this problem is simply 5. Go ahead and try this one on your own. Again, you can't add the factors up top because 3y and y squared have different variables. You can, however, factor out a y, which gives you a y plus 3 in both the numerator and the denominator, giving you that final answer of just y. Then we're going to look at subtraction. One key thing that you might want to pay attention to in the denominator. Notice, I've got p minus 1 and 1 minus p. If you pay attention, those are off simply by a negative. P is positive, p is negative. 1 is negative, 1 is positive. We can change that by flipping the negative up to the numerator. So we're going to keep this first one the same and say 2p over p minus 1. This whole bottom part is going to be multiplied by a negative 1. If I do that on the bottom, I have to do it on the top. So we're now subtracting negative 2p over negative 1 plus p, which can be rewritten to just p minus 1. It's the same thing now. So now that we have our matching denominator, we're going to go ahead and add the numerator. So I've got 2p minus negative 2p, minus a negative turns into a positive. So I end up with 4p over p minus 1. And there's nothing else to simplify there, so that is our final answer. Go ahead and try this one on your own. We already had our common denominator, so we simply needed to subtract the numerators. 3m minus 4m gives me a negative 1m. Negative 5 minus 2 gives me negative 7. Nothing to simplify, so I have negative 1m minus 7 over m plus 4. Now, to deal with situations where we do not have a common denominator, the goal here is to make all of the factors on the bottom match. So the first thing you're going to want to do is look at the factors if you have a trinomial. So things that multiply to negative 3 that add to negative 2. I can replace this expression with y minus 3 and y plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 gives me the negative 2. So now I have my factors on the bottom. Notice I've got a y minus 3 and a y minus 3. This second fraction is missing a y minus 1. So I need to multiply both the bottom and the top by y plus 1. So our first fraction isn't going to change because we didn't have to multiply anything. So 3y plus 2 over y minus 3 and y plus 1. Our second fraction up top becomes a FOIL. So I've got y times y, which is y squared, y times 1, which is 1y, 1 times y, which is 1y, and then 1 times 1, which is 1, And on the bottom, I've still got my y minus 3 and my y plus 1. Now, since my denominators match, I can go through and add up the numerators. So, I've got a y squared up top, so that's going to stay. Then I've got 3y plus 1y plus 1y. That's going to give me 5y. And then I've got a 2 plus 1, which is going to give me 3, over y minus 3, y plus 1. Then we're going to want to double check, is there anything that multiplies to 3 that adds to 5? There is not. So this is our final answer. Go ahead and try this one on your own. Factor that you were missing from the first one is a plus 4, which means the top part turns into a distributive property. And I get a squared plus 4a minus 21 now that we have our matching factors. I can factor 21 to get to 4 into 7 and negative 3. Those two negative 3's cancel out then, and I've got a plus 7 over a plus 4. Same kind of idea is going to happen if we have nothing in common. B is a factor by itself and b plus 1 is a factor by itself. So they don't have anything in common. This means we should multiply by the opposite. So b needs a b plus 1 and b plus 1 needs to be multiplied by b. If we do it on the bottom of a fraction, we need to do it on the top of the fraction. So the first one is being multiplied by b plus 1 over b plus 1. The second one is being multiplied by just b. So up top of our first fraction, again, we've got FOIL. So b times b is b squared. Outside, b times 3 is 3b. Inside, 1 times b is 1b. Last, 1 times 3 is 3. Over, on the bottom, we have b times b, which is b squared, plus 1 times b, which is 1b. Our second fraction then becomes a distributive property. B times b, which is b squared, minus b times 5, which is minus 5b. Again, over b squared plus 1b. Now that we've got our common denominator, I can go ahead and add the numerators. So I've got b squared plus b squared, which gives me 2b squared. 3b plus 1b is 4b, minus 5b is negative 1b, and then plus 3 over b squared plus 1b. And that is all the farther we can take it. Go ahead and try this one on your own. Multiplying the first fraction by 4 on the top and bottom, and the second one by x on the top and bottom, we end up with 20 minus x times 2x, which is minus 2x squared, and then x times 1, which is minus 1x since we're subtracting. Rearranging that to be in standard form, I've got negative 2x squared minus 1x plus 20 over 4x. If you have questions about this or anything else from the lesson, please let me know when you get to class.